Hey guys, I had a question about sig figs and I wanted to see what you think about it. I ran into a bit of a conundrum, so let me explain what I'm thinking. And if you have any advice for me, I'd be interested to hear what you have to say. So naturally, when we do significant figures and we do a calculation, we have to round our result to the appropriate number of sig figs based on our measurements. So in this example, if I want to calculate the area of this box, I would take 15 meters times 29.7558 meters, and my calculator gives me this, which is obviously too many sig figs. And so in order to demonstrate why we should round this to 2 sig figs, I wanted to show the ranges of possible answers so students can see kind of the rationale behind this. So we know that a measurement of 15 has an implied uncertainty of 0.5 meters, so this measurement has this range, whereas a measurement here has an implied uncertainty in the 5th decimal place, so I go down half of that place or up half of that place value. And so you can see that we have a range of possibilities for the area. So if I take the 2 smallest possibilities, I have that area, or if I take the 2 largest possibilities, I have that area, which is more reasonable. I can see that there's a range of possibilities of what the area actually could be based on my measurements, and we can see that this calculator answer is within that range, so that's great. And what was kind of nice about this is you can see that these 2 measurements only agree in the hundreds place and then disagree in the tens place. And so it would stand to reason that I should round this result to the tens place where I have a discrepancy to show that there's uncertainty there. So maybe I would round this result to 450 meters squared, which aligns with my 2 sig fig rule of how I would round to show that uncertainty instead of putting all these digits when I don't really know what they are. But then if I push that further, I kind of run into a problem. So let's say we want to change this number to something maybe with a higher resolution. Let's say I measure to the 10,000th place, and the length over here of this box is actually 15.0015 meters. Okay, now the uncertainty gives me that range, right? A much smaller range of possibilities. But if I multiply this with my other measurement here, I get this range. So those 2 low end give me that area, and then these 2 measurements give me that area. And you can see that they agree to a lot more decimal places or a lot more place values, right? They agree to the 10th place. But what I was curious about is that you can see that the first part that they disagree to is in the 5th significant figure. But if you're thinking about the rules for sig figs, this has 6 sig figs. This also has 6 sig figs. And so what we would normally tell students, or what I would think, is that you should round to 6 significant figures. So you'd round to the thousandths place. But we can see based on this approach of showing the ranges and the possibilities that the range, the lower end and the higher end disagree in the hundredths place before I get to the thousandths place. And so I'm curious, am I missing something here? I mean, you're free to check my math. It almost seems unreasonable to round this result to 6 significant figures when I can see based on this range that there's a discrepancy at 5 sig figs. And so I don't know if you have any thoughts about this. Am I overthinking this? Is there something about sig figs that's more complex that I'm not considering? I'd be curious to get your feedback. So anything you can input would be useful.